Good day, grade 12 learners. Welcome to today's physical science lesson. My name is Mashudu Mamburu. This lesson is brought to you by the Gauteng Department of Education in collaboration with the Saibono Discovery Center. Welcome to this chemistry paper 2 revision to prepare you for your exams. We're hoping that you will enjoy this one. You will prepare well and write and pass. And when we say pass, we mean a good pass and good percentages. Remember, your paper 2 structure is like this. We're still having 10 multiple choice questions with 20 marks. You are going to have structured or long questions with 130 marks. The total is still 150. You are still going to sit for 3 hours. So if you can check, 3 hours is 180 minutes, which simply means that if you say 180 divided by 150, you can see you have about 1.2 minutes for every 1 mark that you get. So that is the time that you can time yourself to check the time so that you don't end up spending more time for fewer marks, so that you are able to deal with your time correctly. In terms of the topics, we'll start with our question 2 and organic molecules, which is our nomenclature. Physical properties, your question 3, your question 4, which is organic reactions. So we'll start with that part. The first part, which is matter and material, the topic organic molecules. And then you are expecting as well 1.1, 1.2, 1.3 to be coming from these organic molecules in terms of your multiple choice questions. Now, again, as we go on, we'll do your rates of reactions, which is your question 5, your chemical equilibrium, your question 6, your acids and bases, usually question 7, electrochemistry, which is your galvanic in question 8, and your electrolytic cells in question 9. So that has been the structure of the paper, and these are the topics. We're going to follow them in that order so that you are prepared and you are able to do well as far as these topics are concerned. And organic molecules, we'll be looking at the 9 homologous series. Remember, you do the 9 homologous series, and then we'll be looking at the IUPAC naming. We'll be looking at your isomers. We'll be looking at your physical properties. Remember, we have 3 physical properties that we do in grade 12, which is your melting point, your vapor pressure, and your boiling point. And then we will do the reactions of organic molecules. Remember, we have the addition reactions, we have the substitution, and then we have the elimination reactions, as well as your cracking, which is part of your elimination reaction. So we'll look at all that, as well as oxidation or combustion reactions. And then esterification as well there, we'll be able to look at that. And the rates of reactions, we look at all the factors that affect the rates of reactions, the issue of the collision theory, chemical equilibrium. We look at the definitions of chemical equilibrium. We look at the factors that affect chemical equilibrium, your CPT. You say it's your concentration, pressure, and temperature. Now we'll look at your acids and bases, and then we'll look at your galvanic cells, your electrolytic cell. Then we'll be done with our paper 2. Now, in terms of the mark allocations, in terms of metamaterials, organic molecules, we're talking here about 58 marks. So you can see that if you do well in under organic molecules, you are already set for good results, because you are able to get a pass, a minimum pass in terms of doing organic molecules under question 2, 3, 1, 2, 3, 4. You are able to get that 58 marks for organic molecules, and then we are saying about 6 marks you'll get them under your multiple choice questions. Then you have chemical change, which is 92 marks. That forms 61.3% of your paper. And then we can go straight to it now, organic molecules, as the first part of our lesson. Remember, we always have been emphasizing the issue of definitions. It's like today, you can do the definitions and make sure that you clean them out, you understand all the definitions, you are ready now, you do even much high-level questions. Now, when it comes to our definition, you must be able to define what are homologous series. Homologous series, remember we're saying these are the series of organic molecules that each differs from another by CH2 group, or they are described by the same general formula. I think that is the definition you like. We're saying homologous series, these series of organic molecules are described by the same general formula. So they have the same general formula. And we said we have 9 homologous series, which I usually like to say AAA, egg, A, and C. And then you know that those are the 9 homologous series that we do. Don't forget them. We know we have the alkanes, the alkenes, the alkynes. We have the haloalkanes, the aldehyde, the ketones, the esters, the alcohols, and the carboxylic acids. And then we are saying that these homologous series, all of them, they differ from one another through the functional group. So it means if you want to identify homologous series, you must know its functional group. I know by now that you know the functional group, and some of these functional groups, they have names. So I'm going to talk to the names of these functional groups. I think before that we name them, and then others were able to describe them, these functional groups as well. So now we look at the issue of what is a functional group, what is a hydrocarbon, what is a saturated hydrocarbon, what is unsaturated hydrocarbon. So you must be able to remember all that. The isomers, the definitions of isomers as well, to say they have the same molecular formula but different structures. Now in this fashion, we're going to look at the chain isomers, the positional isomers, and the functional isomers. Remember, with the chain isomers, iso means same, so don't forget that. So same is molecular formula. So you all the time remember that isomers have the same molecular formula. All of them, they have the same molecular formula. So you are able to say chain isomers have the same molecular formula, but different type of chain. Different type of chain, and then you are able to say it can be branched, the other one can be a straight chain. What are positional isomers? We are saying they have the same molecular formula, but different position of the functional group. Remember, when you say different position, you can say different position of the side chain, of the substituent, or the functional group. So there are 3 things that can be in different position. So remember, with positional isomers, we are saying they have the same molecular formula, but different position of the substituent, of the side chain, or the functional group. So it can be one of those 3 that is different, have a different position. Now, functional isomers, we are saying now for functional isomers, we are saying they have the same molecular formula, but different functional group. Now, you will have seen with your chain isomers and positional isomers, you will find that they belong to the same homologous series. So if you are saying these are positional isomers, they will belong to the same homologous series. But when it comes to functional isomers, because they have the different functional group, and remember when I started, I indicated that the functional group is the one we use to differentiate between the homologous series. So meaning that these functional isomers, they belong to different homologous series. And then we came with that cake so that you are able to remember to say, okay, it is carboxylic acid and esters are functional group. Please don't forget that aldehydes and ketones are functional group, are functional isomers. So all the time when you find your aldehyde and ketones, you will remember that these are functional isomers. They have the same molecular formula but different functional group. And then hence we said cake there to ensure that the aldehyde and ketones, carboxylic acids and esters. And if you check, their general formulas are the same. The general formula for aldehydes and ketones is CnH2NO for ketones and aldehydes. And then for carboxylic acids and esters is CnH2NO2. Remember, learners, that we only have 2 homologous series that have 2 oxygens. It's only carboxylic acids and esters. So immediately when you say structure with 2 oxygens, you know it's either a carboxylic acid or an ester. So please, always we are saying that when you see that the general formula is CnH2O2, you know that that must be that one. So I hope you will always remember these functional isomers as well, because it's one of the things that you find in the exams being asked about them. Now, without any wasting of time, we're going to first deal with multiple choice questions. So because our main aim here is to deal with the issue of problem solving. So we're saying you must be able to solve these problems, and we'll be looking at how to go about the strategies to say how do you go about answering these questions and collecting as many marks as you can. Remember, paper 2 is about understanding. If you understand paper 2, you'll be able to answer all the questions. But without understanding, it becomes tricky sometimes. So it's important that you have understanding of the topic so that you are able to respond to the questions. Now we are saying all topics are examinable on the multiple choice questions. We're saying each question consists of 2 marks. There's special consideration to be given in these questions. You must be able to identify which topic. Always know when you see 1.1 in your paper, you must be able to see that this is organic molecules. And then you must be able to identify the topic which the question belongs, and you collect all the facts about the question. You must thoroughly analyze the question before attempting to choose. So don't just go and choose the answer, analyze the question first. Minimize the distractors to make it easy to choose from the 4 options provided. Remember, with multiple choice, we are given 4 options. We are saying of the 4 options, you have 2 that are generally distractors, and 2 that are one is the answer, the other one is close to the answer. So what you can do, you can remove 2 distractors and remain with 2 options. You see, you are increasing your chances now of getting the answer, which will be 50%. This one, we can't stop to emphasize this one, to say do not skip any multiple choice question. In fact, we are saying do not skip any question, answer all those questions and be able to get your marks. So multiple choice questions 1.1 to 1.10, there must be answers A, B, C, or D. You can't leave 1.7 or 1.8 without making a choice. I'm saying make a choice, ensure that all the 10 have been responded to, because you still have that chance of getting those marks, even if you don't have 100% surety of whether your answer is correct or not correct. Now, with no wasting of time, let's do some multiple choice questions here. Look at this one. It's saying which one of the following is the general formula of alkanes? So we're emphasizing here to say when you're starting with your revision, the first thing you look at is the general formula. You have 9 homologous series, know their general formulas, because they are all of them. We said they are described by the same general formula. So general formula is important because it describes all the homologous series. Now, you will have an understanding of saying when I started here, I said we have 9 homologous series, which is your AAA, A, and C. So there are 9 of them. Now, if you check the first one, which is alkanes, they have a general formula of CnH2n plus 2. And you know that if we remove the 2 hydrogens, we'll have a double bond. Hence, for alkenes, which have now a double bond, the general formula will be CnH2n. To get alkynes, you know that you must remove further 2 hydrogens again. Hence, the general formula for alkynes is CnH2n minus 2. So you must be able to have that information. For haloalkanes, we're saying that haloalkanes is CnH2n plus 1x. So we remove 1 hydrogen, we replace it with the halogen. Hence, we just go to the general formula of alkanes, we remove 1 hydrogen, we put an X there, it becomes the general formula of the haloalkanes. Aldehydes, as I indicated, the general formula is CnH2nO, which means that we are removing 2 hydrogens. We put C double bond O there. We have a C double bond O there, hence we have O. That is only 1 O because there is a double bond to that oxygen. The same with the general formula for ketones is CnH2nO. Hence, we are saying aldehydes and ketones are functional isomers. And then your esters, already I said is CnH2nO2. Your alcohols is CnH2n plus 1 OH. So we're just replacing 1 hydrogen with the OH. Hence, it becomes like that. Then lastly, we have your carboxylic acid, which we said is CnH2nO2. Remember, we said these 2 are functional isomers because all of them, they have 2 oxygens. And they are the only organic molecules that we do with 2 oxygens is carboxylic acids and esters. So you are able to answer this question now. They said alkanes, and you see that alkanes has maximum number of hydrogens, which is CnH2n plus 2. In this case, we're given CnH2n plus 2 as number C. So you're able to get your 2 marks there by choosing the correct answer. You will have seen that this one will be for an alkene, this one will be for an alkyne. And this one, it must be saying plus 1 OH here. There must be a 1 there, plus 1 OH. Then you know that is for alcohol. That is for and alcohol. So we are saying it's important that as you go to the exam, you know the general formula. I think I helped you in terms of you remembering all these general formulas for all the 9 homologous series. Now, as we move, we're able to say name of the functional group. Remember, these functional groups, we said they have names. You must know them by names. These 4 that you are given here, you must be able to know. Now, the name of the functional group for alcohol. So this is an alcohol. What is the functional group? Carboxyl group. Where do we find the carboxyl group? You must know we find carboxyl group in ketones. Ketones is that one that is the C double bond O and the carbons surrounded by 2 carbons like that. Remember, learners, the carbons must always be surrounded by 4 bonds. Even when we are saying draw the structural formula of the functional group, it must show all the bonds there. It must show all the bonds. You can't draw without the bonds, the 4 bonds around each carbon. So for the ketones, if we say you're given ketone, we're saying what is the name of the functional group, you will say is carboxylic group. But if you say draw the structure of the functional group, that's what you will draw for our ketones. Now, I mean for our, I made a mistake. I meant for the, that it will be for the carbonyl, group, which is now for our ketones. I'm correct about ketones, but it must be called a carbonyl. For carboxyl group, we're talking about carboxylic acids, which is now your C double bond O with the OH. But remember, the carbon must have 4 bonds. So the carboxyl group for carboxylic acid, you can just take it from carboxylic acid, then it's a carboxyl group. Then you are able to show it like that. For carbonyl is for ketones. Carbonyl is for ketones. I hope you won't make a mistake as you do your write your exams. Know that carbonyl is for your ketones, and the formyl group is for your aldehydes. Your aldehyde have formyl group. Remember, aldehydes, when you draw the structure, it's a C double bond O bonded to a hydrogen, but all the time the carbon must have 4 bonds around it. A hydroxyl group, remember we're saying it's the OH here, but this OH must be bonded to a carbon, and the carbon must be surrounded by 4 bonds. So with all this, I hope now you know how to the names of the functional groups. You know how to draw the structural formulas of those functional groups, and then when you get this question, you are able to answer it with no problem. I hope that helped you. And then in terms of this question, we wanted the one for alcohols, and for alcohols it was hydroxyl group, which was number D. That becomes your answer now. Now, esterification. Under esterification, we remember we're having an acid and an alcohol, a carboxylic acid and an alcohol. They are reacting together, carboxylic acid and alcohol. It's even much better when you say it's an alcohol and carboxylic acid, because it makes it much easier when you have to write the name of the product. In this case, you are able now to say, okay, the alcohol part, remember the alcohol now is the part, this part that we're having here, it comes from the alcohol, the alkyl group, which in this case, because of 3 carbons, is propyl. Propyl is from an alcohol. Maybe the question you're asking yourself, how do you know that this part is from the alcohol, the other part is from the carboxylic acid? Remember I said carboxylic acid, they have 2 oxygens. So you can see the C double bond O and the O, these ones, you can see that, oh, okay, we still have that from carboxylic acid. But from an alcohol, the OH is not there. From the acid, the hydrogen is not there. That formed water. Remember, during esterification, we are saying it's an alcohol. In this case, let's say it's propanol reacting with 2 carbons, which is now ethanoic acid. So you have propanol and ethanoic acid reacting together. When they react together, we are saying your propanol now has 3 carbons and an OH there. And then we are saying that from this, if you remove the OH from the propanol, if you remove that OH from here, and then from the acid, you remove the, remember, it makes it easier because we were saying that an acid is a proton donor, so which is a hydrogen ion. So we just take the hydrogen there. It makes much easier for you to remember. I found it easy when you do it that way, to say you will put your carboxylic acid this side and say this is our carboxylic acid, and from the carboxylic acid we take the H, from the alcohol we took the OH, and we form water. And if you remove this, you will have this structure, and this structure, now the alcohol becomes the alkyl. Now this will be propyl, and the carboxylic acid becomes ethanoate. Remember, it is only carboxylic acids and esters that has their names have two parts, propyl and ethanoate. It's not one name. It's just like a name and a surname. But all the other homologous series, 7 of them that we do, when we write the name, is the same name. There's no space between. But when you are writing esters, you can write propyl, ethanoate with the space between them. But all the other homologous series, with the exception of carboxylic acids and esters, you write the name as one name. So all the structures we're going to name, no matter how long the name is, you will write one name, only for carboxylic acids and esters, where you will have propyl, ethanoate as 2 different ways. I think you got that, and this is how you do. Remember, you can be asked about the catalyst that we use for esterification. And we are saying because we are removing water, and you know sulfuric acid is a good dehydrating agent. So the catalyst there is sulfuric acid. So don't forget, it's a reaction of an alcohol with a carboxylic acid to form an ester plus water. Be careful, because you can be asked to write structural formula. Remember, when you say structural formula, it means you must show all the bonds in your structure of the reactant, which is your alcohol, in this case propanol, ethanoic acid. You draw the structures, and then you show the ester that is formed, which is now your propyl ethanoate, and then you show that water is one of the products that are formed there. And then you are able to show the catalyst is sulfuric acid. Please don't forget that. That is esterification. Have it with you. It will help you as you answer questions. Now, let's go to naming of organic molecules. Now, I find it easier to name using these 3 steps, because I know you might have practiced many steps that you use for naming, and there's nothing wrong with what you have practiced, but there is another way. I'm just showing you another way of doing it, and I find it easier because you are only looking for 3 things for you to be able to name a structure. So what you look at, the first thing that you look, if you check here, I'm saying we have a prefix, we have a parent name, and then we have a suffix. Those are the 3 things that we look for. But as you do your naming, you start with the suffix to say you look at the functional group, because the functional group will tell you the homologous series. And if you know the homologous series, you will be able to get what we refer to as suffix. Suffix is name ending. How will the name end? The name, if it's an alkane, the name will end with an ane, alkene, in, alkyne, like that, alcohol, all, aldehydes, alone, and oic acid and OH for the esters. So we are saying the first thing that you'll check how the name will end. That is the first thing in our process. The second thing, you look for the longest carbon chain. This becomes a challenge to some of the learners. So we're emphasizing to say, please, when you're choosing a longest carbon chain, sometimes you find that the structure is bent. It's not straight. Then you only count the straight carbons, and any carbon that is bending, you think they are no longer part of the longest carbon chain. If you can still draw a line on your longest carbon chain without lifting a bend, it is still part of the longest carbon chain. So look for many options of the longest carbon chain before you commit to say this is the longest carbon chain. Then you will be able to do your naming. Now, that is the first thing. You look for the functional group. You are able to check the homologous series, and then you put the suffix down. So let's say if it was an ane, you'll say the name will end with the ane. And then longest carbon chain. If you find 1 carbon, it's a mid, 2 carbons, eth, 3 carbons, prop, 4 carbons, but, pent, hex, hept, and oct. I know you know that, and then you're going to implement that. So when it's 6 carbon, you'll say, oh, it's hex. So it must be hex. So that is the parent. The parent is hex. The suffix is ane. So you know that is hexane. Is there any a substituent? Now, this is important, learners, to say in our syllabus, we are dealing with the substituents, which are the halogens. Your halogens is your bromo and your chloro. And you've seen in other years where fluoro and iodo as well might be asked as well. So it's important to know that we can have bromo, we can have chloro, we can have fluoro, we can have iodine, which is iodo, in terms of our prefix. And then from the other part, we can have our alkyl group, which is your methyl, your ethyl, which is the substituent or the side chains that we are having. So always the name, as long as we are having bromo, chloro, methyl, or ethyl as a substituent, the name will start with them. And the other important thing about the substituents is that they go with the number. You check in which carbon do you find bromo, chloro, methyl, or ethyl. So all the time, tell us that in carbon number 2 we have. So you can say 2 bromo, hexane. And remember what I said when I started the lesson. I said always we write one name, no space in between, with the exception of carboxylic acids and ester. So we're able to move. I hope you have that. So now we're going to apply that knowledge that we're talking about of naming to say, will we be able to name? Now look at the structure that we're given here. The first thing that you will do, we said we'll start at the end, which is the suffix. How do we know the suffix? We look for the functional group. Remember, the functional group is that part of the name. When you remove a functional group, you would remain with something that looks like an alkyl group. So, for example, if I remove this, I will have an alkyl group. If I remove that, then I know that is my functional group. That is my functional group, and that is a Q is for carboxylic acids. Carboxylic acid, meaning that the name must end up with the oic acid, because the functional group told me the homologous terrace is carboxylic acid. So I know this is a carboxylic acid. What informs me is the functional group. Now, oic acid is for this carboxylic acid. Now, we said now the second thing is the parent, longest carbon chain. Now, I will say this is carbon number 1, our terminal carbon there. So carbon number 1, carbon number 2, carbon number 3, carbon number 4. You can say number 4 to the left or to the right, it doesn't matter. As long as if I can draw a line there without lifting my pen, I know all these carbons are part of the longest carbon chain. I can go to the left or to the right. The option is mine. I chose to go to the right. Now, if you check how many carbons in the longest carbon chain is 1, 2, 3, 4. Now, the mistake that learners do, they write boot here. They'll say, okay, the parent is boot. So we don't have a name that is called butoic acid. The name must be butanoic acid. So now you can see that it means now when you are dealing with alkanes, alkenes, and alkynes, those hydrocarbons, when you are dealing with them, you can do the meth, the prop, the but. But when you deal from aldehyde, ketones, esters, everything, you must write the whole name butan. Without, you just remove E from the alkane name to say, okay, when you have 4 carbons, is butan. Then you put the suffix, which is oic, then it's butanoic acid. Please don't make a mistake of saying the name is butoic acid, because we won't mark that. That will be wrong. So it must be butanoic acid. Do you have any? Remember, we've done the suffix, we've done the parent. Now we're going to the prefix. What will the name start with? Remember, we said we are looking for substituents. We are looking for halogens. We are looking for methyl. We are looking for ethyl. Now, do we have any? We don't have halogens here, but we have methyl. So we have a methyl in carbon number 2. We have 2 of them. So you see that is a 2,2 already. Do we have another methyl? Yes. In carbon number 3, we have another methyl. So 2,2, 3. So you can see that our name must be 2,2, 3 trimethyl. Remember, between the alphabet and the number, there must be a hyphen. We will penalize you if you don't show that hyphen there. If you don't show the commas there between the numbers, you'll be penalized. So those might look like small things, but they are most important. And remember, we said now this is an acid. So you will say 2,2, 3 trimethyl butanoic acid. You can see our option is number A there. Then we're able to answer the question. I hope that helps you when you deal with your naming. Now, I want to get off the naming so that we can go and deal with other sections, but I felt it would be important to consolidate using this because this is the type of diagrams that you usually will get in question 2. To say, as you get that diagram, the most important things for you to remember. Remember, I wrote here FH Jemison for you to remember. To say the first thing you look for is the functional group. Do we have any functional group? Do we have anything that makes this not to be an alkane? That's what you are looking for. Do we have something that changes? Remember, if you have a functional group, let's say you have an alkane, if you have a functional group, it will change this ane part to make it something. Like for example, if you have a double bond, the ane will be in. So you'll say it's an alkene. And then if it's triple bond, you'll say it's alkyne. You see, that's what functional group does. They change the suffix of the name. The functional group, what they do that. But if you look at this structure, we don't have anything that will change the ending of the name. So I can say the suffix of the structure is an ane. Why I said it's an ane because this is a haloalkane. Remember, haloalkanes is haloalkane. So haloalkane ends with ane. So this is a haloalkane, so the name will end with an ane because we have a halogen there. Now, if we check this is an A, now which one is carbon number 1? That is the thing that our learners still struggle with, but I hope this will help you to be able to identify carbon number 1. To say this carbon and this carbon are in competition to be number 1. Which one is number 1? Somebody will say the one on the left, somebody will say the one on the right. So it's not about you having favoritism to say I favor the one on the left or the one on the right. No, you are saying this one want to be carbon number 1, this one want to carbon number 2. Let's go to the second carbon because all of them, they look the same. There's nothing that says the left or the right is carbon number 1. This one is saying I'm carbon number 2. Even this one is saying the same thing, that I am carbon number 2. Now, who will win this battle to be carbon number 2? Now, this carbon, what does it have? It has a methyl group. It has a methyl group. It's saying I'm carbon number 2, I have a substituent. This one is saying I'm in carbon number 2, I have a substituent, and my substituent is bromo. This one is saying my substituent is methyl. So which one? The mistake that our learners always make is that they will stop and say bromo must be carbon number 2 because it is alphabetic preference. No, we can only do the alphabetical preference when we are done with checking other carbons. Let's go to carbon number 3, for example, here. When we check carbon number 3, we have a methyl from the left. We have a methyl from the left. But when we check carbon number 3 from the right, we have nothing. We have no substituent there. So now the most substituted site is the one on the left. Hence, it will be preferred when you are numbering. I want you to understand that. To say carbon number 2 and carbon number 2, all of them are having substituents because we said our substituents are halogens and our alkyl group, which is methyl and ethyl. So we are agreeing that we are having substituents in carbon number 2, substituent in carbon number 2. But now in carbon number 3, we have another substituent. So we have a site that is mostly substituted, and that is the site that must be preferred in terms of numbering. So carbon number 1, number 2, number 3, number 4, number 5, this becomes carbon number 6. Please ensure that you do that. Now, you start now. We said the name will end with the ane because there is a haloalkane. Haloalkanes end with the ane. Now, we have 6 carbon, and 6 carbon we said is hex. So this must be hexane. Do we have substituents? Yes. In carbon number 2 and carbon number 3, we have methyls. So carbon number 2 and carbon number 3, we have dimethyls. We have dimethyls in carbon number 2 and carbon number 3. In carbon number 5, we have a bromo. Remember, when you write a name, you are going to use alphabetical order. So your name will start with 5 bromo because B comes before M. B comes before M. Remember, the di is not part of the alphabet because it's just showing that you have 2 methyls there. So it's 5 bromo, 2,3 dimethyl hexane. So you're able to write your name like that. and get your marks. However, if you find that this maybe was 2 marks, we'll be able to give you mark for the hexane there, the parent chain, to see that the longest carbon chain was hexane. For the substituent as well, 2 marks. And if it's 3 marks, then you'll get marks like that. But now, if it's 3 marks, you'll get marks even for the correct numbering. But if you numbered from the right, you made a mistake, you numbered from the right, you will have said this is 5-bromo, 4,5 dimethyl hexane. You still will get the marks for the hexane and all that. Not all is lost, but rather write it correctly and get all your marks. So please do that. So that is the issue of the functional group, the homologous series. The general formula for haloalkanes, we said is CnH2n plus 1x. The molecular formula, then you do the molecular formula for the structure. You do the structural formula which is given. Then you look at the is there any condensed structural formula, because you must know how to condense the structure. It's important for you to know how to condense. How do you condense the structure? You are saying on this carbon we have CH3, so you will say that is CH3, CH bonded to CH3. Put it in brackets. When you see CH3 in brackets, you know it's a substituent. Now you have a CH, CH3, you have a CH2, CHBr, and you have a CH3. That's how you will write the condensed structure. Please write your condensed structure, because some of the time you will be given a condensed structure like that one. Be able to draw a structural formula so that you are able to see everything clearly. I hope that helps you. And then we talk to the issue of isomers and the naming, which is what we have done. I hope as you go through, you will do all the questions. If you are given a molecular formula like that one, you must be able to first draw the structural formula so that you are able to see that is this an alcohol or something. Maybe you are not sure, but when you draw, you are able to see clearly that we have 3 carbons that you are given, which is your CH3, and then you have your CH2, you have your CH2, you have your OH. So you can see that was an alcohol, and the name of that alcohol is propan, because it's 3 carbons, is propan 1-ol, propan 1-ol. Please, it's important for you to show that the alcohol is in carbon number 1, because it has a what? It has a positional isomer, which the OH can be in carbon number 2, then it will be propan 2-ol. So please know that this is important to show the position. Everything that has a positional isomer, you must tell us the number. Where will we find the functional group? I hope that helps you. And as we move, and you'll be able to look at the issue of naming, and you will name with no problem. The issue of isomers, you'll be able to do the isomers. The issue of esterification, you'll be able to deal with the esterification. The issue of the name of the functional group, you'll be able to name the functional group. You have seen the carboxyl group for carboxylic acid. You have seen the carbonyl for ketones. You have seen the formyl group for the aldehydes. You have seen the hydroxyl group for the alcohols. Please know the names, know how to draw the structure. When you are given the condensed formula, you must be able to put it in there in a structural formula. When you are given a molecular formula, draw structural formula, because the question can come anyhow to say you are given this formula, be able to convert to another formula. Now I'll move to physical properties. Remember, we said we are only doing 3 physical properties in terms of physical science in grade 12. We do the melting point, the vapor pressure, and the boiling point. The first thing, definitions. We have always been emphasizing that. That has been our song, to say know the definition of melting point. We are saying now it's not a point. Please, it's not a point. It's a temperature at which, write everything in full, to say it's a temperature at which the solid phase and the liquid phase are at equilibrium. The solid phase and the liquid phase are at equilibrium. Please remember, we just write in full ways to say melting point is a temperature at which the solid phase and the liquid phase are at equilibrium. Now, vapor pressure, another equilibrium again. So we have 2 equilibriums, which in this case, we are saying for vapor pressure, we are saying vapor pressure is not a temperature, it's a pressure exerted by vapor. It's a pressure exerted by vapor at equilibrium with its liquid. But for vapor pressure, because the molecules have a lot of energy, you must say in a closed system. So we are saying it's a pressure exerted by vapor at equilibrium with its liquid in a closed system. Why are we saying closed system? Because these molecules have a lot of energy. If you don't close the system, they will escape. But our first equilibrium for the melting point, we didn't say in a closed system because the energy is very low there, because things are on the I state, the solid phase is only trying to be a liquid phase. So I hope that helps you. The last definition, which is boiling point. We are saying boiling point is not a point as well, it's a temperature at which the atmospheric pressure is equals to the, so you must be able to talk to the vapor pressure is equals to atmospheric pressure. Let me tell you about this definition. Last year we had learners who will say atmospheric pressure is equals to vapor pressure. So now it's like the atmospheric pressure is the one that is now wanting to be equal to the vapor pressure. Instead, it is the vapor pressure that is increasing until it's equal to the external pressure. So start with vapor pressure when you write the definition of boiling point. Otherwise, if you make the vice versa, you'll be penalized. So we are emphasizing there to say this is a temperature at which the vapor pressure is equal to the atmospheric pressure, not atmospheric pressure is equal to vapor pressure. Please, I've put emphasis on that. The issue of forces, I know you know the forces by now. To say our alkanes, alkenes, and alkynes, AAA there, they have London forces, which are the weakest intermolecular forces. Most likely, less energy would be required to overcome the intermolecular force. Our Hague there, which is our haloalkanes, aldehyde, ketones, and esters, they have dipole. Remember, you have dipole in addition of the London forces. And then we are saying the dipole are stronger than the London forces. And your alcohols and the carboxylic acid, they have hydrogen bond. So these are the strongest intermolecular force. But remember, learners, we are saying alcohols has one side of hydrogen bonding, while carboxylic acid has two sides of hydrogen bonding. So that tells you that the strongest of all the 9 homologular steroids will be carboxylic acids because they have two sides. So meaning that if you have to overcome the intermolecular forces, we're talking about two, which is hydrogen bonds there. So we're saying carboxylic acid has the strongest intermolecular forces, which means more energy will be required when you have to overcome intermolecular forces in carboxylic acids as compared to alcohol, because alcohols are forming one side of hydrogen bond while carboxylic acid forming two cards. We are moving. This question is all about, remember the issue of variables. The variables, remember we talk of 3 variables, which is your independent variable, which is the variable that the experiment manipulate, the one that we are changing. What are we changing? That is our independent variable. And our dependent variable, what are we measuring during the experiment? And at the end of the day, we are saying that we will have the other one that is controlled variable. So when you deal with this experiment, this question 3, always have that in mind. See the investigation there. See the investigation to say, I'm going to check now. We're given, for example, in this case, our independent. What do we change? According to the exam guideline, we change the intermolecular force, we change the functional group, we change the chain length, we change the molecular mass or the branch. So I just say if chain mob, so that you don't forget. To say, okay, in a structure, you'll find that we can change the intermolecular force. We can have different intermolecular forces on the structures that were given. We can have different functional group. We can have different chain length. We can have different molecular mass. We can have different branches. We can change the branches. So that is what we change is independent. So it starts with independent either. So the independent variables, according to our exam guideline for this section, will be those intermolecular force, functional group, chain length, molecular mass, and branch. And others will talk to the issue of surface area. But you will know that when we talk about surface area, still you'll be talking about the issue of chain length and all that, which are related to what we're talking about. Now, the question can be in a graph form. So you're expecting come the day of the exam, Monday, you are able to find a question in a graph form. If the question is in a graph form, we are saying now you are having your independent variable on the x-axis. You know that by now. and then you are having your dependent variable on the y-axis. So what are the three dependent variables? Is the melting point, vapor pressure, and boiling point. Those are three dependent variable. So if they're asking what is a dependent variable, you know it can only be those three physical properties. What are the independent variable? It will be those that were given there. So in this case, what are we having in the independent? We're having number of carbon. So you can see it's a chain length. As the chain length, what happens to the boiling point? Remember, the boiling point depends on the independent variable. So as the number of carbon atoms increases, the boiling point increases. So you're able to see that relationship. Please avoid using directly proportional when you're answering questions under this section. Rather say, as the number of carbons increases, the boiling point increases. So you're able to have that relationship. You are referring how the independent variable affects your or impact your dependent variable. So the question can be in a graph form, or the question can be in a table form. Immediately, you are able to check to say, okay, we know most the dependent variables, we said is only three. The dependent variables, there are only three now. We said it's melting point, boiling point, and vapor pressure. In this case, it is vapor pressure. And then now, what is the independent variable? Let us make a mistake of thinking that hydrocarbon is the independent variable. No, go deep to the structure, compare structure A, B, and see what is the difference between them. So if you can check, you will see that we're having 1, 2, 3, 4, 5. 5, that would be pentane, 5 carbons. We have one branch. Now we have 2 branches. So you're able to know that, okay, our independent variable for this question, when you look at the structure, you are able to say, okay, what is changing here is the number of branches. So it's the number of branches. As the number of branches, remember it's 0 branch, 1 branch, 2 branches. As the number of branches increases, as the number of branches increases, what happens to the vapor pressure? You see that, the number of branches increases, the vapor pressure increases. You can't write they are directly proportional. No, you talk about increase and decrease. I hope I've emphasized that. So you can see that always you are checking now the effect of the independent variable on the dependent variable. Then you are able to say, okay, as the number of branches increases, the vapor pressure increases. What does that mean? It means as the number of branches increases, the strength, because the first thing you're looking at the structure, you're able to say what is different in the structure. You said it's the number of branches. So as the number of branch increase, what happens to the strength of intermolecular force? That is the second question you ask yourself. The first question, you're saying what is changing? What is different between this independent variable? What is different between them? You are saying is the number of branches. Now, what is the effect of the number of branches on the strength of intermolecular force? So you will see that as the number of branches increases, the strength of intermolecular force decreases. And as the strength of intermolecular force decreases, vapor pressure increases. Remember, it's only vapor pressure that increases with decrease in the strength of intermolecular force. I want you to have that in your mind. To say with vapor pressure, you are doing like that. You are saying as the strength increase, vapor pressure decrease. So as the strength decrease, vapor pressure will increase. In this case, you can see from A to B to C, the strength is decreasing because the more you are having now, more branches is the more the strength of intermolecular force is decreasing. And when the strength decreases, the vapor pressure will increase. Now, what would have happened if the question was about boiling point? You know that as the strength of intermolecular force decrease, boiling point will decrease. As the strength of intermolecular force decrease, melting point will decrease. So you see that with melting point and boiling point, the strength increase, boiling point and melting point increase. But when it goes to the issue of vapor pressure, when the strength increase, the vapor pressure decrease. I wanted to emphasize the issue of vapor pressure as compared to the other two, because the question can be on any of those three. Now, without any wasting of time, we can move now to a strategy to say explaining the difference in physical properties. How do you go about answering this question? That's what this slide is talking to. It's saying to you, step number one, you check the difference in the structure. I've talked about that. I said if chain mob, intermolecular force, functional group, chain length, molecular mass, or branches. So you're able to check what is different there. That is the first thing you will check to say what is changing. Then you are able to know what is changing is this one. That is your first mark there. Then you are going to look at the effect of the independent variable on the strength of intermolecular force to say is this factor going to increase the strength or decrease the strength. Number three, the energy needed to overcome intermolecular force. We are always emphasizing, let's not use the word break down the intermolecular force, rather let's say to overcome. Because if you are changing from solid to liquid, the intermolecular force is still there. It's not broken, it has just been overcome. It's no longer as strong as it was. It was stronger in a solid form, but in a liquid form, it is now still there, but in a weakened state. That's why we just overcome the intermolecular force. We don't break it. Now let's move and be able to do the question so that we don't have no problem. Then we know that we are moving forward. Now, without any problem, we are able now to look at an example here to say our example. The first thing is saying define the term boiling point. So you will be able to define boiling point. Remember, we said it's not a point, it's a temperature at which the atmospheric pressure, the vapor pressure is equal to atmospheric pressure. Don't make that mistake of putting the atmospheric pressure before the vapor pressure. It is the vapor pressure is equals to the atmospheric pressure. I think I've overemphasized that. You got that. What is the relationship between strength of intermolecular force and boiling point? We just talked about it to say as the strength of intermolecular force increase, the boiling point increase. As the strength of intermolecular force increase, the melting point increase. It is only with the vapor pressure. When the strength increases, the vapor pressure will decrease. So it does the difference as compared to the others. Now we're saying what is the relation? Number three, you look at the diagram again to say we're having a table here, and then in our table, still you will look at your independent. You can see mostly you have your independent variable. On your left, on your right, you have the dependent, what you are measuring on this table. So you're able to see that, okay, what is changing, what is different here? When you look between propane, propan-2-one, they have different intermolecular forces because we are talking about an alkane and a ketone. When you look at propanone and propan-1-ol as well, they have different homologous sterics, different functional group, different intermolecular forces. So you can see, but C and D is an alcohol and carboxylic acid in D, you are able to see that they have the same intermolecular force, which is hydrogen bond. But remember, we said one site for propan-1-ol, two sites for propanoic acid. A carboxylic acid has two sites of hydrogen bond, and alcohol has one site. I think I've emphasized that. And then the question is saying refer to the type and strength of intermolecular force to explain the difference in the boiling points between compound A and B. So A and B, but the question has already told you that focus on the type and strength of intermolecular force. So the first thing you're going to talk about is the type of intermolecular force. To say, okay, propane, they have London forces. And then when it comes to propan-2-ol, you can refer to them as A and B so that you don't have to write the full name now. To say, okay, in A, which is propane, we have London forces, and then in B, we are having our dipole. That is the type of intermolecular force. And then the strength, now you are comparing the strength to say, okay, B is stronger. Now you are saying the dipole in B is stronger intermolecular force than A. A has less strength of intermolecular force. So you tell us which one is stronger. The first thing you said, what are the intermolecular forces? The second thing now, that is the structure. You're looking at the structure to say what is different. You're saying is the intermolecular force. And you identify the intermolecular force as London and dipole. Number two, you are comparing the strength. Hence, you are saying ice here. We are saying ice here. So number one, we are saying you look at the intermolecular force. You said it's London force and dipole. And then you tell us, you compare the strength. Which one is stronger? We are saying B has a stronger intermolecular force than A. And then you are able to say now, energy required. How much energy will be required to overcome the intermolecular force? So you're able to say more energy is required in B than in A. Always the stronger one, you will require more energy. Energy to do what? To overcome the intermolecular force. So you will always answer you like that. Your independent variable first, you compare the strength, and then you tell us about the energy that is required to overcome the intermolecular force. The same when you are dealing with the question between C and D. Remember, C and D, all of them have hydrogen bonds. They are all having hydrogen bond. But we said an alcohol has one side of hydrogen bond. A carboxylic acid has two sides. So when you go to number two, you are comparing the strength on the ice there. When you compare the strength, you'll say propanoic acid or D has stronger intermolecular forces than C, because it has two sides while C has one side. And then the last one, which is the energy now, you'll say more energy. As long as you are stronger, more energy will be required to overcome the intermolecular forces in D than in C. So, and we are saying here, this is we are emphasizing, this ice is in bullet form. Please, learners, let it be in bullet form so that your bullets will mark them independent of each other so that we don't have issues there. So don't write a paragraph, don't write a letter, please. Just write in bullet form. The first one, you are telling us the intermolecular forces. The second bullet, you are comparing the strength. Which one has stronger intermolecular force? The last one, you're telling us which one will require more energy to overcome the intermolecular force. The last question, 3.4, it says, is compound B a gas or a liquid at room temperature? So you are able to check room temperature, learners. It means 25 degrees Celsius. So 25 degrees Celsius. So if you look at B is at 56, it boils at 56. So it can't be a gas before it boils. So it must be liquid. So you're able to choose liquid as your answer there. I hope that helps you as you deal with these questions and you are able to collect these marks when you get this question. Thank you. In terms of question 3, organic reactions now, without wasting of time. Now, we have these acronyms that we are using and we find them useful. Remember, when you are having unsaturated hydrocarbons, when you are having them, you know that the unsaturated molecules, they can undergo only one. We only do one reaction for double bonds. When you see a double bond, you know it must be addition. We only add on the double bond. So it must be easy for you. When you just see a double bond, you know the only reactions that are double bond in grade 12 are undergoing under question 4 is addition reaction. So you don't have to ask. For example, when I see put 2 in here, I know that this step 1 reaction is addition because we only have USA. We don't have any reaction that starts with another thing. And then we are saying unsaturated will always undergo addition reaction. Now, you have unsaturated becoming saturated, that's addition. Hence, you can say we're having U here. Definitely, this is S. So it must be addition reaction. So we're saying USA so that you are able to remember that. Now, meaning now that, okay, we're having put 2 in, it became now saturated. It means we've added. When you are having saturated, like we're having here, we said this is saturated. There are 2 options. Saturated can become unsaturated, can form a double bond. A single bond can form double bonds. So saturated can be unsaturated, or saturated can remain saturated. So if saturated remains saturated, we are saying that is substitution. But if saturated becomes unsaturated, we are saying that reaction is elimination. Now, if you look here, we're having both 2 in that underwent addition and became saturated, and then saturated is either undergo substitution or undergoes elimination. And if you can check here, there is no any other, when we substitute, we need another reactant. So here we only have compound A, it's not reacting with anything. So it's becoming now, it's forming compound B plus CH4. So you are able to see that this must be elimination. While being saturated, becoming unsaturated. So this must be eliminated. What did we eliminate? We eliminated CH4. What do we call that special kind of elimination? We call it cracking. What is cracking? We're saying it's the breaking down of large organic molecules into smaller, most useful ones. So you are able to see that, okay, it means here we're having an alkane because we do the cracking of alkanes, of our saturated hydrocarbons. So we're having an alkane. If we had butene, it means the alkane was butane. So meaning that here we had butane, and the butane now undergoing cracking. Remember, under cracking, we are saying you will form an alkene plus alkane, or you'll form alkene plus H2. So those are the products for cracking. So in this case, we have an alkane. So we know that this is an alkene. So we're having 4 carbons on boot, then it's separated into CH4, meaning that alkane is CH4, which is methane, meaning that alkene now would be compound B, and the alkene with 3 carbons would be propene. So you are able to say, okay, this is propene. Now I want to check with you. Will you refer to this as propene or prop1-ene? So there is no need for you to refer to it as propene, because even if I draw propene, I will put a double bond like that, H, like that. We have our H, and another H there. Then you can see that even if I put a double bond this side, it's still the same structure. Hence, it has no isomer. It has no positional isomer. So it is propene. We just call it propene. There's no need for me to say prop1-ene, because when I say prop1-ene, it's because there is prop2-ene or the other positional isomer. So it doesn't have a positional isomer. Doesn't matter whether the double bond is in this carbon or on this carbon. It will always be called propene. Hence, I will say I'm having propene plus CH4, which is cracking. So I see that this step 2 was step 3. Step 2 was cracking of butane to form alkene and alkane, and we are saying the alkene is propene, the alkane is methane. So now we did what we refer to as cracking. And then the propene, already we said, when you see a double bond, you see addition reaction. So you can see that propene is unsaturated. So for it to be saturated, USA. So it must be addition. So you are able to say this must be addition reaction. Then you are able, with no doubt, you are able now to say, okay, what did we add? Dibromo. It means we're adding Br2, which is now bromination or halogenation. The type of addition is halogenation. And if we were to be asked what step 1, what type of addition, it will have been hydrogenation, because we have added hydrogens there to form compound A. Now, without wasting time, let's go to this practice diagram as I conclude on the reactions. We are saying this is one of the questions that learners have not been doing well, but it won't be with you. With you, I'm confident that you are going to do very well in this section, because the main thing you know is to check this is propene, is unsaturated. And any arrow that comes from unsaturated is saturated, it forms saturated and is addition. So I know that any arrow which is C in this case will be addition, because it's unsaturated. This must be saturated. So that is addition. This HBr, when coming from prop1-ene, as long as the arrow is coming from unsaturated, I know that the product is saturated and the type of addition of reaction is addition. Prop1-ene forming propane, I know. Unsaturated, saturated, the reaction is addition. So you are able to see that, as long as I'm coming from a double bond, as long as the arrow comes from the double bond, that must be addition reaction. Please, let's do well in this question. Now, any arrow that forms a double bond, that forms saturated, remember we said USA. So from unsaturated, we form saturated, the reaction is called addition. In this case, we are saying if you come from saturated, for example, D, let's look at reaction D, this one, is from saturated to form unsaturated. So that must be elimination. So from saturated to unsaturated, the reaction is elimination. Please do that, you will enjoy this section. Then you are able to say, okay, from compound X, we can be able to, when it goes back, is elimination. From this alcohol, when you remove the water, is now elimination. So every arrow that comes back here, you know that is elimination. So you can see that reaction B and D are elimination, and reaction A, C, and the HBr1 are addition, because all of them are coming from a saturated forming, unsaturated forming, saturated forming, unsaturated, which is elimination. Now, if we are having a saturated forming another saturated simply means that we don't have a double or a triple bond between carbon atoms. That's the meaning of saturated that we are referring to. So as long as whatever is there doesn't have a double bond between carbon atoms, that is saturated in this way that we are talking about here. So you can see from saturated to saturated reaction E, we are starting with saturated, we are forming another saturated, and that must be substitution, because it said triple S. I want you to practice this until you get it, until you understand and be able to look. You just look, this is saturated forming saturated, that is substitution. So these reactions, the type of reactions, you get them with no problem. So the first question was, what type of reaction? What type of reaction? The second one, we want to be specific now to say what type of addition. What type of addition? You are able to say we have added hydrogens here, so it's hydrogenation. What type of addition? We have added water to form alcohol, so we call it hydration. What type of addition here? We are adding hydrohalogenation and a halogen, so we call it hydrohalogenation. So we are always looking at what was added to form the product. So in other words, we are saying if you are having prop 1 in, which I can just quickly show the structure like that. I know I said it doesn't matter to call it prop 1 in because the in is in carbon number 1. So I'm still standing with that. It's fine. Prop 1 in or propene as a structure that we are given there. Now you are able now to say, if we have propene becoming propane, here, reaction number A, propane, which is that structure. Now you are able to see that we are having propene becoming propane. So what is the difference? You just draw the structure and check the difference there. You will find that this has the 3 carbons, 3, 4, 5, 6 hydrogens, but this one has 3 carbons and 8 hydrogens. So you can see the difference there is 2 hydrogens. So you are able to see the type of reaction. You see the importance of drawing structural formulas, because if you draw the structural formulas, you will see what is different. Then it will be easier for you to check what type of reaction. So you'll see that we have added 2 hydrogens there, hence we are saying it's hydrogenation. For an alcohol, when you have that becoming now an alcohol, you will see that we have an H2 and then O. So you're able to see that the difference is water there, and that is hydration. So I hope you will practice many using this type of example, and then you will do well in terms of reactions. But I won't leave these reactions without talking to the issue of reaction conditions, because that's where our learners don't allow yourself to go and write exam without knowing the reaction conditions for addition reaction, for elimination, for substitution. Know the reaction condition. Even for esterification, we said the catalyst there is sulfuric acid. Please know all the catalysts. I'm emphasizing that to say always know. For example, when you are adding hydrogens, we are saying the catalyst or the reaction condition is platinum, palladium, or nickel. You can write any of those. So you must know all of them, and then it will help you. Remember, for HBr there, when you add HBr, hydrohalogenation, we're saying no water must be present. No water must be present when you are adding HBr. So always know, when you are dealing with water here, this side, when you are adding water, water and sulfuric acid friends. So it must be H2SO4 as your catalyst there. So always know the reaction conditions for all the reactions that you are having. I hope that will help you and you will get many marks as you practice this. I'm confident that it will help you as you answer many other questions on that one. The last question that I want to talk to on the reactions is the combustion of our alkanes. To say you can have combustion, which is the reaction of these organic molecules with oxygen to form carbon dioxide, water, and energy. Please, immediately when you are given any organic molecule, in this case we're given butane, just to write butane plus oxygen forms carbon dioxide and water plus energy. Already you got 1 mark for the reactants, 1 mark for the product. Before you balance, I know most of our learners, they spend more time trying to balance. And as you balance, we always say it's good when you do the chore, the chore one, to say you will balance the carbon, the hydrogens, and the oxygens, and you are able to come up with your balanced equation. Then you get your 3 marks for balancing. But even if you didn't balance, if you got 2/3, it is still 66.7%, which is still a good achievement. So we are saying know it, but it will be better if you get total. And we are always encouraging you to get total. With no waste of time, we're going to move now to question 5, which is our rates of reactions. Now, under rates of reactions, the first thing that we are emphasizing is to define the rate of reaction, which we are saying now is the change in concentration of the product or reactants per unit time. Please put it like that. We had the year in 2022 where learners were saying the rate at which the concentration of the product change per unit time. You cannot use rate and per unit time in one statement. Remember, if you say is the rate of change in concentration, the rate of change in concentration of products or reactants, you are done. You can't say the rate and say per unit time, because rate is per unit time. Please, I'm emphasizing that is the rate of change in concentration of products or reactants, or you can simply just say is the change in concentration of the products or reactants per unit time. But you cannot use per unit time and rate in the same statement. Now, calculate the reaction rate from the given data. You must be able to calculate the rate of reaction. List the factors that affect the rate of reactions. Remember all those factors. You have your temperature, you have your concentration, you have your surface area, all the factors that you have. You have your catalyst, the nature of reactants, and then lastly you have your pressure. So all as those factors that affect the rate of reaction, and you have seen that most of them, when you increase them, you increase the rate of reaction. You must be able to explain in terms of collision theory how the various factors affect the rate of chemical reaction. And we are saying you must know that as we talked about this in question 3 of organic molecules. Still here, you will find your questions in table form or graphs, and mostly you will be dealing with experiments that were done or investigations that were done on different experimental techniques. And we are saying you must be able to define your positive catalyst. You must be able to now have the Maxwell-Boltzmann distribution curves. So those are things that you must emphasize as far as you are dealing with the rates of reactions. If I give this quickly with no wasting of time, to say if you are given magnesium that is solid reacting with hydrochloric acid to form magnesium chloride and hydrogen gas, you must be able to know the factor, because if you have a solid, you know that the factor there is surface area. So if you were to increase surface area, you can't increase surface area of an aqueous solution, you'll increase surface area of a solid. Hence, it's important there to be able to know that, oh, surface area has to do with solid now. And then the ACl, which is aqueous solution, we talk about the concentration. Remember, we talk about the concentration of a gas and the concentration of aqueous solution. And then we're having a gas there. On the gas, we talk about concentration, we talk about pressure. Remember, pressure affects only gases. Now you're able to see that these are your reactants forming your products, and then how many atoms. You are able to see that we have H2 there. What substance are the substance in, the state there. It's important to know that this is solid, hence we said surface area will affect aqueous solutions. And how will you measure the rate of this reaction? Remember, when we're measuring the rate, we can look at the change in mass of magnesium per unit time. So you can expect a question like that, where you will get a graph now that shows the change in mass. Remember, the reactants, when we start with more mass of magnesium, so it decreases with time until the reaction reaches its completion. Remember, when the curve straight becomes straight like that, we're saying it has reached its completion. So you know that this will be the mass which is measured in grams per unit time there. So you're able to see that, okay, as far as you find a graph of this form, you know that those are the reactants, because the reactants are being used up. We start with more reactants, but as the reaction proceeds, it does decrease until we have our limiting reagent that will be used up. Now, if I was to show the concentration of HCl, still I will draw a graph that goes like that. Then I will show that here I'm dealing with now mole concentration of HCl, which is in mole per cubic decimeter. And then as the reaction time increases there, then you see that as long as it's reactants, we're expecting a graph like that. And we're saying the rate of reaction is highest as when the curve when the curve is the steepest, but as time proceeds, you can see that our reaction now is slowing down. When it becomes straight, you are saying that the reaction has reached completion. Please don't be confused with when it has to do with equilibrium, where you will think that it has reached equilibrium. Remember, in question 5 on under rates of reaction, we are not talking about a closed system. So the reaction it becomes complete, or because one of the reactant will be used up. Please have that understanding. So the graphs like that are the graphs of the reactant. It can be the graph of the concentration. So if it's concentration, you know that it's change in concentration per unit time. Then the SI unit there would be mole per cubic decimeter per second. So this one, it change in mass, it will be grams per second. So all the time you are able to check now. If you find a graph that goes like that, you know it's a graph of the product, because the product starts from 0 and increases until the reaction is complete. Now you are able to see that, okay, that can be the volume of hydrogen gas, and you know that our volume can be measured in cubic decimeter, and then you know that we have our time there. So you're able to see that when you see the graph like that, is the graph of the product. When you see the graph like that, is the graph of the reactants, which is some of the questions that we have shown there, and then which is what I was explaining. The other thing that is important is for you to be able to know what are the instruments that we use, the issue of the gas syringe and all that, and how do we measure it, and then how to measure the gas that is being produced there. And if you check, you will see that most of the reactions that you were asked about were just changing that one, just changing calcium. We put calcium carbonate there, we put your zinc, we put your copper, different things that we are putting, but sodium thiosulfate, all that, we just change that. But the reaction, we find that is mostly related to that, and the graph is mostly like that. And we said the rate of reaction is the change in concentration of the reactant or product per unit time. I hope you have that. Now, the main thing now is the issue of the coalition theory. Now, under coalition theory, remember we're saying that the reacting particles, they must collide effectively with one another. How do they do that? They must have enough kinetic energy. So we're saying the first thing that is important for a reaction to take place, we must have enough kinetic energy, and we must have correct orientation. If we have correct orientation and enough kinetic energy, we are saying that now the particles will collide, and they will collide effectively, which we refer to it as effective collision. Remember, you have your endothermic and exothermic graphs that you have done in grade 11. 100% you must know how to draw them, because you will definitely get questions that relate to them. Now, if we were to look at a question that talks to the graph now, the Boltzmann distribution curve. Now, I want you to have an understanding here to say, how do I know this graph is a graph of temperature, of increasing temperature, increasing concentration, or increasing adding a catalyst? Remember, we talk about the concentration, we talk about the temperature, we talk about the catalyst. So how do you know? Now, as you are getting this graph, because you know this graph, we're having particles here, but these particles have different energies. And the particles that have enough energy are the ones that we have passed the activation energy. Any particle that have more equals to energy equals to activation energy, or more than activation energy, we are saying that has more. So we are saying that those ones will be able to form products. Now, as we increase the temperature, the first factor there, as we increase the temperature, you see what the graph does. It shifts to the right, but it does touch. It touches there. Temperature touches, don't forget that. To see, as you see the graph now, they will be touching one another. You know that we have increased temperature, and we are saying when we increase temperature, you increase, according to the definition of temperature, is the average kinetic energy of the particles, the measure of average kinetic energy of the particles. So when you increase temperature, you increase the average kinetic energy of particles. So don't forget that. And then that is the first bullet when you're using collision theory, to say what will happen if you increase temperature. Increasing temperature, increase the average kinetic energy of the particles. Number two, we are saying now more effective collision per unit time. So that's what we are saying. There will be more effective collision per unit time. Please, if you write a 5-letter word instead of 6-letter word, you won't get all your marks. So it's important that you are saying more effective collision per unit time. 6-letter word. Hence, I'm saying MacPut. You can't write MacPut, just saying it so that you remember. It's more effective collision per unit time. And then you are saying now, if you increase temperature, you increase the average kinetic energy of the particles, more effective collisions per unit time. You'll say you will increase the rate of reaction. And then depending on the number of marks, you can really say more particles will have energy greater or equals to the activation energy. So more particles will have energy greater or equals to activation energy. You say that in ways more particles will have energy greater or equals to activation energy. So those are the 4 bullets that we are writing. Now, when you go to concentration, the only bullet that you are changing is the first bullet. The other bullets, they just remain as in that order. So what am I saying? I'm saying the concentration does not touch. Remember temperature, we said temperature, the graph touches. But here, the graph is on top of that other graph, as you can see. Because when you increase concentration, remember concentration is N over V. So when you increase concentration, you are increasing the number of particles per unit volume. You're increasing the number of particles per unit volume. So you are able to do that. And then the next bullet, increase in concentration, increase the number of particles per unit volume. That is your bullet number 1. Just write in ways. And then you are able to write the other bullets as I indicated in previously, to say you will have more effective collision per unit time. You will have increase in the rate of reaction. You will have more particles that have energy, greater or equals to activation energy. Then you are able to write it in that fashion, and you are able to get your marks there. Now, let's go to a catalyst. Remember, a catalyst now, we said it speed up the rate of reaction. But how does it do that? It lowers the activation energy. So when it comes to a catalyst, we are saying a catalyst will provide an alternate pathway of lower activation energy. So it provides alternate pathway of lower activation energy. That is the first bullet. The other bullets are the same. You'll have more effective collision per unit time. You'll have increase in the rate of reaction. Then you can talk to more particles having energy greater or equals to activation energy. I hope you got that, and as long as the question is about these 3, you'll be able to know that we said for the temperature the graph shifts and touches, and for the concentration we said it just goes on top of that because we are increasing the number of particles per unit volume. And then for the catalyst it just moves inside, and then we are saying it provides an alternate pathway of lower. You can see activation energy was there, now it's going backward. It's alternate pathway of lower activation energy. You can see that it lowers the activation energy to allow more particles now to react effectively. So you are able to answer the question of coalition theory. Let's look at the question. 3 experiments A, B, C are carried out to investigate some of the factors that affect the rate of decomposition of hydrogen peroxide. The balance equation for the reaction is given as H2O2, water, and O2. Identical samples of hydrogen peroxide are used in each experiment. Now, if we look at this experiment, the main thing to look at experiment number A. What do we have? Temperature is 25. There is no catalyst. Experiment number B. Catalyst is 25, so same as this one, but with catalyst. So this one, it has a catalyst. This has no catalyst. This has a catalyst. Experiment number 3, temperature is high, but without a catalyst. So you are able already to see the factor that is affecting the rate of reaction. So in this case, they're saying which experiment, A or B. So your question is on A or B. Is the reaction rate the highest? Use the collision theory to explain the answer, and then you are able here to be able to say, okay, what is the A and B? A, no catalyst. B, with a catalyst. So you are able to see that, oh, the factor is a catalyst. What did we say about a catalyst? Bullet number 1, we said it provides an alternate pathway of lower activation energy. We said more effective collision per unit, increasing the rate of reaction, more particles with energy greater or equals to activation energy. So you're able to write those bullets and you are able to get your marks there. I hope that helps you, and it helps you as you do your calculations as well for rates of reactions. Practice different ways of doing the calculations of rates of reactions, and you'll be able to collect your marks. Now, chemical equilibrium. You can see now under chemical equilibrium, we talk about now the rate of the forward reaction is equals to the rate of reverse reaction as the definition of chemical equilibrium. However, in the exam guideline, it says it's a dynamic equilibrium. It's a dynamic equilibrium when the rate of the forward reaction is equals to the rate of reverse reaction. And we're saying the factors that affect equilibrium is your concentration, your pressure, and temperature, which I know you learners will call it capital CPT, so that you don't forget that there are only those 3 that affect chemical equilibrium. And then we are saying now you'll be able, when you talk about temperature, you know that we have endothermic reaction and exothermic reaction, where we are saying increase in temperature favors endothermic reaction. Decrease in temperature favors exothermic reaction. So you are able to remember all that intermendo and detomexo, so that you remember how these factors affect equilibrium. Now, the other important thing is the issue of equilibrium constant, your Kc, to say how do you go about calculating your Kc. Remember the Kc expression, we're saying you will only include gases and aqueous solution. Because the concentration of solid and liquids remain constant, so they have a concentration of 1, hence you won't include them. Now, equilibrium or factors affecting equilibrium constant, we are saying is only temperature. Factors affecting chemical equilibrium is 3 of them, is concentration, pressure, and temperature. But Kc is affected by only temperature. So be careful when you get a question of Kc where temperature is not a factor, to say the increased concentration, you know that only temperature can affect equilibrium constant. The issue of Le Chatelier's principle, knowing how to state Le Chatelier's principle, and then drawing the graphs. You must know the graphs of rates and the graphs of concentration as far as this section is concerned. Now, with no any wasting of time, we're saying avoid omitting keywords from the definitions. Remember, we have definitions like open system, closed system, where we're saying the open system, it interacts with its environment, while a closed system is isolated from its surrounding. And we are saying now a reversible reaction, we are saying the products can be converted back to the reactants. The products can be converted back to the reactants. And chemical equilibrium, where we said the rate of forward reaction is equal to the rate of reverse reaction. Remember, we are saying the rate. You can't say forward reaction is equals to reverse reaction. It must be the rate of forward reaction is equal to the rate of reverse reaction. And this chemical equilibrium can be homogeneous. When it's homogeneous, we're saying the reactants and the products, all of them, they are in the same phase. They can all be gases or solids, or as long as the phase is the same, we'll say that is homogeneous equilibrium. But when it's heterogeneous equilibrium, we're saying the reactants and the products, they are not in the same phase. So when they have different phases, now we refer to that as heterogeneous. And then we said, now make sure that you know the types of reactions like endothermic and exothermic, and then you know the graph. If forward reaction is endothermic, the reverse reaction would be exothermic. And we say you must be able to work through the worked example first, so that you are more comfortable with questions and answers as you are practicing. That's what we are emphasizing. Work through the exercises given on your own before looking at the answers. As you will be practicing many questions, you do the questions first before you go to the answers. Then you can go to the answers to look for the answer, for the correct answer. Now, if you look at those graphs, you are able to say this is how we define chemical equilibrium. You can see on the first graph there that we have the forward reaction and the reverse reaction. And for forward reaction is starting at a very high forward reaction, and then the reverse is starting from 0. And then you are able now to see that when the rate of forward reaction and the rate of reverse, when the graph becomes like that, you know that now we have reached equilibrium. So equilibrium, the rate of forward reaction and the rate of reverse are equal. And if you can look here, when the rate of forward reaction and the rate of reverse reaction at equilibrium, we're saying the concentration of the reactants and the concentration of the product, as we said, remains constant. Remember, when we're dealing with rates of reactions, we said that this reaction, when the graph becomes straight like that, we say direction is complete. But now, when it becomes straight like that, we are saying we have reached equilibrium. How do we know? The concentration of the reactants, the concentration of the reactants and the concentration of the product remains constant. Please don't forget that. But in terms of exam guideline, when you define a chemical equilibrium, you say it's a dynamic equilibrium when the rate of the forward reaction is equal to the rate of reverse reaction. Now, let's look at one question that talks to equilibrium constant. You are given ammonium chloride, which decomposes in a container at 340 degrees Celsius according to the following equation. You can see that the ammonium chloride is solid. But now we have gases, which is our ammonia gas and HCl gas. Hence, we can continue with the calculations here. What is the meaning of the double arrow? The double arrow in the above reaction. Remember the double arrow, we said the reaction is reversible. And reversible reaction, we said you define it as the product can be converted back to the reactant or vice versa. Now, the graph below, not drawn to scale, shows how the amount of ammonium chloride in the container changes with time at 340 degrees Celsius. If you can check, we are given now the mass. When you see mass, paper 2, when you see mass, you see number of moles. You see N equals to mass of another mass. So immediately when you give me mass, you are giving me number of moles, because I will convert the mass to the number of moles. So you can see that we have 10.7 grams initially as the mass of ammonium chloride, and then we are giving the graph is for ammonium chloride, don't forget, 8.1 at equilibrium. Ammonium chloride, the mass is 8.1. And then the question was equilibrium is reached at 340 degrees Celsius. Calculate the equilibrium constant Kc at this temperature. The volume of the container is 500 cubic centimeter. Now, I want to emphasize this for you as we deal with this question. The number one, the issue of the volume of 500 cubic centimeter. Remember, our volume must be in cubic decimeter. So you got to divide that by 1,000. So your volume would be 0.5 liters or 0.5 cubic decimeter. So don't forget that. Remember that volume, you already have a 1 mark, because at the end, you're going to divide by volume, and dividing by that 0.5 will give you a mark. So you have a mark for using volume. Now, the main thing that I want to show is that the first thing that you will do, you will get the number, you have initial number of moles, which is 10.7. You must know the molar mass of ammonium chloride, which is 53.5. So initial number of moles, remember, you are icing here, and then others, they want to say rise, where they can really show now the ratio. But if you can look in this one, the ratio is just 1:1:1. So now, if you check, you can see that initially you had 12.7 grams of ammonium chloride, and then the number of moles is 0.2, so you were able to do that. And then at equilibrium, you have 8.1. You divide it by the molar mass, you get the number of moles, which is 0.15. So for ammonium chloride, you are given a number of moles. You have number of moles now at equilibrium and number of moles initial. And if you look at the difference of that is 0.05. And then once you have one change, learners, already your rise table, you are able to complete it. All you need is one change, because once you get 0.05 there as one of your change, you use mole ratio to say 1:1. So if you 1:1, it means the number of moles here will be the same, because it's 0.05 is to 1 multiplied by that 1 gives you 0.05. So it will be the same. Don't forget, when you are changing, the change there is in accordance to the balanced equation there, the mole ratio there. So it's important that if the mole ratio is the same, it means that we'll have the same there. But if it was 2 there, it would mean that it will be 0.05 times 2. If there was 3 there, it will be 0.05 times 3. Please don't forget the importance of the mole ratio, because when you're marking, you can see that you have the mark for the ratio. So when we're marking, we'll look at the ratio. As long as you got the correct ratio, you'll get that 1 mark of the ratio. And then the next mark now will be now for your change. Now you can see here you are changing something. You are saying now on the product side, we started with 0, the change was 0.05. We started with 0. This one and this one same. This one and this one same on the product side. Then how did you get that? You said that plus this, you got this. We give you 1 mark for adding there to get that 0.05 there. It's another second mark that you got. Now you divide the 0.05 by 0.5, which is the same as multiplied by 2. So 0.05 divided by half, that will give you 0.1. So dividing by 0.5 again is 1 mark. So please, learners, don't leave without collecting this mark of the ratio, the mark of addition and subtracting on the table, and the mark of dividing by volume. Now, another mark which is important is the mark of writing the Kc expression. Remember, we said the solid and the liquid is 1. So you'll say, okay, the product that we're having is NH3 and ACl. I want to emphasize here to say if you say Kc equals to product, concentration of products over concentration of reactants, and then you come and write, after writing this, you come and write this, we'll mark this and we'll mark this wrong. Please, learners, don't write this in your answers. I'm emphasizing that because over the years, you find that there are learners who write Kc expression by starting to write that. That is not the Kc expression. When you say Kc expression, we are referring to the Kc expression of the question that you have been given, which in this case is Kc equals to NH3, concentration of NH3 multiplied by concentration of HCl. Fortunately, we didn't have the coefficients. If you have coefficients, remember the coefficients becomes the power there. And then you are able to do that. Even if you can divide by 1, there's no problem because the concentration of the solid is 1. It's fine. So dividing by the 1 is the same as you didn't do anything. Then you substitute correctly. You got a mark, then you get all your marks there. And then you are able to do this. I hope you practice different types of Kc questions, and you will be ready as you are going to. You can be given concentration, you can be given a mass as we were given here, you can be given number of moles. Yours is to always be able to do what you're supposed to do and be able to write and calculate your Kc. Now the issue of the equilibrium graphs, to say, if we look at this graph, if we look at T1, you can see that at T1 there is a sharp increase of N2 there. Then that shows you that the concentration of N2 was increased. Concentration of N2 was increased. And then N2 is a reactant. Remember, when we increase the concentration of the reactants, the forward direction will be favored. So what is the forward direction? The NH3. You see that the NH3 is increasing there. It shows that forward direction is favored. But as we increase N2, most of this H2 will be used so that we reach equilibrium. It means as N2 goes up, H2 must decrease. Hence on the graph, we can see H2 is decreasing. It's because a lot of it now is reacting with the N2. Please let us have that understanding to see that, okay, when you increase the concentration of a reactant, the forward direction will be favored. But let's look at T2. All the factors are sharply increasing. So you can see that all of them are sharply increasing. And when all of them increase or decrease, all of them the same, sharp increase in all of them, you must know that the factor there is pressure. So increasing pressure increases the concentration of both of all these reactants and products. So all of them will increase. But remember, what did we say? We say increase in pressure favors the least number of moles, or the lowest favors the least number of moles. So the least number of moles must be favored. And in this case, the least number of moles now is the ammonia, is 2 here. Always you'll say how many moles here? We have 1 N2 plus 3 H2. So we have 4 molecules of the gases on the reactants. On the products, we have 2 molecules of the gas. So we are able to say as we increase pressure, it favors the lowest, which is the 2 now. The lowest is favored. How do you know that? The NH3 goes up after that. This is the response. Remember the Electrolysis principle to say if the conditions of a system at equilibrium are disturbed, a new equilibrium will be re-established. How will that happen? It will be re-established by favoring the reaction that oppose or the reaction that cancel the effect of the disturbance. So that's what the Electrolysis principle is being applied there to say what is the disturbance with increased pressure. How will it respond? It will favor the least number of moles. Hence, now the least number of moles is favored. The last at T3 there, what has been changed? You can see that there is nothing that concentration does not sharply increase of all the 3 species. And if you look at that, we are able to say this must be temperature, because if you increase temperature, you can increase the concentration. When you increase temperature, you are increasing the average kinetic energy of the particles. Hence, all of them, they remain where they are. But what did we say? We said intermendo. Intermendo, we said increase in temperature favors endothermic, decrease in temperature favors exothermic. Then you are able to see that in this case, what is going to happen when you increase temperature, endothermic reaction will be favored. Which one is endothermic? Forward reaction, we are told here, is exothermic. Reverse must be endothermic. That's all you always do. When forward is exo, reverse is endo. And when you increase temperature, you know that it must favor endo. So which one is endo? Is our reverse. What are the reverse? N2 and 3H2. Is N2 and 3H2 increasing? Yes. You can see H2 is increasing. N2 there, the graph is increasing. So it shows that they are favored. The one that is increasing is favored. Then you know that, okay, we increase temperature. But if the forward direction was favored, you will have seen that we have decreased temperature, because decreasing temperature favors exothermic. So practice as many questions. I know it will be helpful to yourself. Now, with no wasting of time, we'll move to the 7th question, which is acids and bases. Now, here we're just going to emphasize now as you prepare yourself to say definitions. Remember how many definitions we have under acids and bases. You have Arenas' model, where Arenas said an acid is a substance that produces hydrogen ion in aqueous solution. He said a base is a substance that produces hydroxide ion in aqueous solution. And now came in Laurie Bronsted that said an acid is a proton donor, a base is a proton acceptor. Don't forget those common acids and common bases that we use. Your common acids being your HCl, hydrochloric acid, your sulfuric acid, and your nitric acid. Those are common strong acids. And then the common weak acids that we are having as well your phosphoric acid, your carbonic acids, and etc. So always remember the weak acid and the strong acid so that you are able to know them. Now remember the group 1 elements, LINAC, your LINAC, which is your lithium, sodium, and potassium. The hydroxides are the strongest bases you will ever get. So when we talk about strong bases, we're talking about those, including some of the group 2 elements or hydroxides. They are able to give you those strong bases. And then your weak base, we're talking about your ammonia, your calcium carbonates, your carbonates, and then you know those, they will give you weak base. So what the definition of a strong and a weak? Because some of the learners, they think that if you have a strong acid and you pour a lot of water to a strong acid, it becomes weak. No, a strong acid remains strong. When it has more water, it means that it's dilute. So I'm bringing the issue now of dilute versus concentrated. Remember, concentration we said is N over V. So dilute simply means we have less number of moles of particles per unit in proportion to the volume of water. But concentrated, we are saying we have more number of moles of a substance in proportion to the volume of water. So please remember, concentrated doesn't mean that dilute. I mean to say, it doesn't mean that it is now weak. It can still be dilute strong acid. What makes it dilute is that we have less number of moles per unit of volume of water. So we have more water added onto it. It makes it dilute. But strong is about ionization. To say a strong acid will ionize completely in aqueous solution to form high concentration of hydrogen ion, and a weak acid will ionize incompletely to form low concentration of hydronium ion. And then when it comes to base, we are saying now a strong base will dissociate completely in water or in aqueous solution to form a high concentration of hydroxide ion, and a weak base will dissociate incompletely, and then you are able to get those marks. Hence, I indicated that there are a lot of definitions that you will do under this section. The issue of hydrolysis. Remember, we're saying hydrolysis is the reaction of salt with water, not and. We said the reaction of salt with water. The issue of neutralization, which is now the reaction of an acid and a base to form salt and water. So all these many definitions that we are having under acids and bases, we are saying revise them and know how to apply that. Now, with no wasting of time, I will take just one question from the prelims. We're given hydrochloric acid as a weak acid there. And then the question was define a weak acid. So you are able to define what a weak acid that it ionizes completely in aqueous solution or in water to form low concentration of hydronium ion. Now, a sample of hydrochloric acid has a pH of 4.5 at 25 degrees Celsius. So already you are given the pH. They are saying calculate the concentration of hydronium ion. So you must be able now to move between the two. To say, okay, sometimes I know the formula is pH equals to minus log H3O plus. Please just copy the formula from the data sheet as is given, and then you were given the 4.5 there, and then that is minus log H3O plus. So what you have to do is anti-log. We simply say you can just write your formula as H3O plus is equals to 10 to the power of minus pH. That is 10 to the power of minus 4.5. And then you just use your calculator, and then you are able to do that to get your answer as far as that is concerned. And then if I use my calculator, and then you are able to say, okay, it's 10 to the power of minus 4.5. You just do like that, and then you are able to get your answer, and then it's 3.16 times 10 to the power of minus 5, I think, like that, and then you are able to write your answer. Now, will the pH of the sodium fluoride solution be greater than 7, smaller than 7, or equal to 7? That question is simply saying, if you have a salt that is called sodium fluoride, is undergoing hydrolysis. So for hydrolysis, we are saying that now, if you are having sodium fluoride, the first thing you do is that you must separate the sodium fluoride into sodium ion and fluoride minus. And then you are able to say, okay, this one is from sodium hydroxide, which is a strong base. This one is from HF, hydrogen fluoride, which they told us is a weak acid. Obviously, this is a salt of a strong base and weak acid. So the solution will be alkaline or basic. So you are expecting that it must have greater than 7. Remember, basic means the pH. Remember, our pH scale is from 0 to 7 to 14. So anything less than 7 we said is acidic, anything more than 7 is basic. So you are able to see that if you have a strong base and a weak acid, it will definitely form a basic solution, and the pH will be greater than 7. So you are able to answer such questions. And then, as I indicated, you do your calculations like that. You can just say that, and then you substitute, you get your 3,16 times 10 to the power of -5. And then you are saying it's greater than 7 or it's basic. In another question, you say, is it basic, acidic, or neutral? In this question, they said it's greater than, less than, or equal to. So you are able to say, in this case, it's greater than 7, which means it's basic because it's a strong base that reacts with a weak acid. Then you are able to do that. Now, the last part of our grade 12 topic, which is now redox reactions. Now, as we conclude, now, I just want to be straight to it and not waste no time to say the first thing that you are going to emphasize is that those definitions, loss of electron, we said is oxidation, we get our reducing agent, which is oxidized. Our gaining of electrons, we say is reduction, which is our oxidizing agent that is reduced. Please, these mnemonics will always help you to remember as you and when you have forgotten to say, okay, you know that loss of electron is oxidation. And this substance that undergoes oxidation, we call it reducing agent. What is a reducing agent? It's a substance that undergoes oxidation, or a substance that loses electrons, or a substance that is oxidized. So you are able to do that. And we are saying gaining of electrons is reduction. What is the oxidizing agent? We're saying it's a substance that undergoes reduction, or a substance that gains electrons, or a substance that is reduced. So you're able to always remember that. And then the definition of an anode and a cathode. Remember, ode there is from the word electrode. So anode is an electrode where oxidation occurs. I didn't say an anode undergoes oxidation, because you'd find in other reactions that the anode is there as your conductor, and then because your anode must be solid, so you find that the solid is not the one that is involved in the reaction. You'll understand as you do the question. The cathode, we're saying, is the electrode where reduction occurs or take place. So we always say an ox, so that you don't forget that at the anode, oxidation, which is loss of electron, takes place. On the cathode, red cat. You are able to remember all that. Then others will say oil rig and all that. But all these, they are there to make you remember. The issue of oxidation numbers that you have done in grade 11, revise the oxidation numbers as you prepare yourself for the exams. Electrolysis, remember under electrolysis, we're talking about only 4 processes here. We do a decomposition of copper chloride, where we are forming copper and Cl2. So our product must be copper and Cl2. We are just looking for the 2 reactions that will form copper and Cl2. And if you are to check in our table, you'll have seen that the reaction that forms copper is copper 2 plus, like that, forming copper like that. And the reaction that forms Cl2 is 2Cl minus, forming Cl2 plus 2 electrons. So you are able to know that at the anode, we are having that, at the cathode, we are having that. And when you know those 2 reactions, you are able now to do the overall cell reaction. The next reaction, which is now electrolysis of our concentrated sodium chloride solution. In this case, we are having sodium chloride. However, our product, you have to know that at the anode, we are always having our chlorine gas being formed. As long as we have a halogen there, it will be at the anode. So at the anode, you are going to have your halogen, and then you know that in this case, sodium plus is not unlike here where copper is formed. Sodium plus is not formed. We're only forming Cl2, but the sodium plus, because it has it's not a stronger oxidizing agent than water. Water is the one that gains the electrons here. So don't forget this one is water that gains electrons, and then that forms hydrogen gas and 2OH minus. So you're able now to see that this will be like that. So you're able now to see that under this reaction, we are reacting sodium chloride. So we can say 2Cl minus plus 2 water. It forms Cl2 plus H2 plus 2H minus. So you can see that there are two gases that are being formed on the when we have the overall cell reaction is chlorine gas and hydrogen gas. So don't forget the main thing for electrolysis of sodium chloride, we are saying it's not sodium that is being formed. We are forming hydrogen gas and 2H minus. Please, it is water that gains the electrons, not the sodium plus. Please, I'm emphasizing that because one of those questions, I think you have seen in the prelim, you had a question about sodium chloride, and that is the expectation that you must have. Now, as we look, the other two processes now, which is purification of copper, as an example of you can be purification of any other metal. But what you have to understand is that as long as you are having your cell, you must be able to know that you are having your cell there. The metal that you are having must be at the anode. Remember, we're saying positive anode, and then we're saying negative cathode. The cathode is the small one in this case of electrolytic cell. So you are able now to see that an under electrolytic cell, that's what you are expected to understand. To say, okay, at the anode, we're having now the metal. If it's purification of copper, we're having copper at the anode. What happens? At the anode, we lose electrons. So the copper loses electrons. At the cathode, you write the same reaction in a reverse way. So that's what happens at the anode, one arrow all the time, sorry, and then that forms copper. So always have that understanding to say for purification, I will have the metal losing electron and the metal ion gaining electrons. The same with electroplating, because for electroplating, we are saying, say you are having silver, you want to plate, let's say a ring or a medal with silver, you will do the same here as I indicated. Then you will have silver metal that loses electrons at the anode. At the cathode, you just write the same reaction in a reverse manner. Please practice this, and you will see that these two processes of purification and electroplating, you have the metal losing electron. On the other one, you have the metal ion gaining the electrons. Hence, we say the concentration of the electrolyte remains constant. The concentration of the electrolyte remains constant. Why do we say that? We say that because the rate of forward reaction is equal to the rate of reverse reaction. So you know that here for purification and for electroplating, the concentration of the electrolyte will remain the same. However, on this one, the other two processes, the concentration of the electrolyte will decrease. So in short, that's how I would like to summarize that. Now, under galvanic cell, which you are saying the first thing, you define your galvanic cell to say under your galvanic cell, you are expecting here under galvanic cell to say now a galvanic cell, it converts. The energy conversion is very much important for the definition, that it converts chemical energy to electrical energy. You write it in full. It converts chemical energy to electrical energy, while electrolytic cell is from electrical energy to chemical energy. Don't make a mistake, because we were writing paper one of saying that of talking about mechanical energy. Remember, mechanical energy is in paper one. Here we talk about chemical energy to electrical energy for galvanic cell. And then we are saying know your electrolyte. Remember, electrolyte, we are saying this is a solution that conducts electricity. Your exam guideline is saying that it's a substance that has been dissolved in water to form ions, to form a solution that conducts electricity. So that solution that conducts electricity, we call it an electrolyte. So we are saying all that you got to be able to do. And if I can quickly go through the questions as we wrap up, to say consider the reaction represented by the following equations: 2Ag plus copper, 2Ag plus copper 2 plus. Now here, learners, we want to emphasize that the question can come in different ways. Here you are seeing we're having overall or net cell reaction. It's a net cell reaction. You can see we're having now on the reactant side all the time, we're having a stronger oxidizing agent, which is positive, which is this one is silver plus, and stronger reducing agents. Remember, your reducing agents are your metals that you find on the right of table 4A or 4B. So you can see that we're having strong oxidizing agent reacting with a stronger reducing agent to form the weaker reducing agent and the weaker oxidizing agent. Remember, the oxidizing agent is those ones, those mostly positive ones, that are oxidizing agent. And when you look at the question, it's saying which one of the following represent oxidizing agent, then you're able to see that our oxidizing agent in this equation is Ag plus. Don't make a mistake of saying it's copper 2 plus. Copper 2 plus is an oxidizing agent, but it's not as stronger. The stronger ones are always on the reactant side. So always on the overall cell reaction, you are having on the reactants the stronger oxidizing agent and the stronger reducing agent. So that must help you as you deal with this type of questions. On this one now, you were given an in the electrochemical cell, the letters X and Y represent two metals electrodes. When the cell is functioning, electrode X gains mass. You see, immediately when you say electrode X gains mass, you know when we gain mass, gaining of electrons, you start now to think about the cathode. That we said that the cathode, remember by definition, say gaining of electrons is reduction, which is the oxidizing agent, which is reduced, and that gaining of electrons happened at the what? At the cathode, because we said red cat reduction occurs at the cathode. So you know that the way we have X increasing in mass, that is the cathode. And immediately when you write your cell notation, we're saying all clever learners, or we're saying A, B, C. So we're saying you start with the anode. So we know X already, that there is gaining of electrons. So the X must be on the cathode side. And then on the anode, we know that it must be Y now that is losing electrons. Another thing that I want to emphasize as we conclude is to say it doesn't mean that the anode on these cells will always be on the left, because there are learners who think that the anode is always on the left, but you can see that our anode is on the right of our half reaction there. So always have that understanding. So our anode, which is our Y now, our Y, and you know that when you write the reactions, when you write the anode, you always start with your Y, which is solid. Outside it must be solid. Y solid is forming. So in terms of the option, we have Y2 plus, Y2 plus. So you know that is forming Y2 plus, which is aqueous solution. And then we have a salt bridge, and then you have your X. So if you check on the option, this option would be wrong, because you don't start with ions. You always start with solids on your half reactions. And then we are able to move as we conclude. And then you check this one is Y becoming Y2 plus, that forms X plus, forming your X. So option number A becomes your correct answer, and you are able to move as I indicated. I just wanted to, when I conclude, to use this table to remind you to say on the left here, you would find an arrow that shows you now increasing oxidizing ability. So we have oxidizing agents on the left, we have reducing agents on the right. So as you go up there, you are getting stronger reducing agent. As you go down, you are getting oxidizing agent. So all the time our oxidizing agents are these ones on the left. On the right, you have our reducing agents. That will help you as you answer questions. And I'm saying this table is the one that will help you. Remember, I was saying this is the table of what? Of standard reduction potential, which means this is the table of ability to gain electrons under standard conditions. Say, what are the standard conditions? Remember, we said standard conditions. Our standard conditions is a temperature. You write it in full. Temperature of 25 degrees Celsius. It's a concentration. It's a concentration of 1 mole per cubic decimeter. You can even say initial concentration of 1 mole per cubic decimeter, and a pressure of 1 atm or 101.3 kilopascals. Remember, pressure works for gases. It only affects when you have gases. So if they say write 2 and you see that you don't have any gases, just write the first 2, which is your temperature and your concentration. I hope you will do as many questions under this section as possible, and you will be prepared, and you will use this table in order for you now to identify the oxidizing agent and the reducing agent, in order for you to calculate the EMF of a cell. Remember, EMF of a cell, we said is E cathode and minus E anode. We are saying now, as we finish this, to say that ensure that you copy the formula the way it appears in the data sheet. And you will have seen that in table 4b, you will be having obviously your anode at the top and your cathode at the bottom. That helps you. If I was to use the example of a zinc copper cell, where we have zinc 2 plus 2 electrons forming zinc, and copper 2 plus 2 electrons forming copper, you are able to know that, oh, this side, as we go down on the table, you will see that we are finding a stronger oxidizing agent. As we go up, we are finding a stronger reducing agent. So you are able to see that, as I indicated, that the reaction is between a stronger oxidizing agent, which is now copper 2 plus, which means in the reactant we have copper 2 plus, and stronger reducing agent, which is zinc. So that those two will form copper and zinc 2 plus. So you are able to see that the reaction is always between stronger oxidizing agent and your weaker strong oxidizing agent and stronger reducing agent. So you are able to get that. And then if they say which one is an oxidizing agent, you are able to follow the arrow. Say the strong oxidizing agent is copper 2 plus. That shows you that copper 2 plus is an oxidizing agent. Reducing agent is zinc, because it's the one there, according to the arrow, is at the zinc is at the top there. You can see we have our zinc there. Copper is down there on the table. So you are able always to be able to do that. Even for calculating EMF, you are able to know that that is negative 0.76, that is positive 0.34. So cathode, your cathode is down there. I said A, and then cathode is there. So ABC, you are able to know that A at the anode comes before the cathode. So you have the anode in table 4b at the top, the cathode at the bottom. Then you are able to know that this will be 0.34 minus 0.76, and that gives you 1.1 volts. And then you are able to say this is spontaneous. It is spontaneous because no energy is needed as compared to the electrolytic cell. So as I conclude, I will say your galvanic cell is exothermic and is spontaneous, meaning that no energy is added. But when you talk about electrolytic cell, it will be non-spontaneous, because we have a source of direct current that is added, and we are saying it's endothermic because energy is absorbed. I hope this all that we have done. I know paper 2, lot of work. You will work and ensure that you make us proud and you write your exams, you pass. So I will finish this by saying, see you next time. Goodbye.